Hello students, welcome back to my channel once again. In the previous video, we have learned preparation of carboxylic acids, both aliphatic and aromatic students. Hope you have watched the video and also noted down all the methods in your notebook. Okay, so this video I am going to explain an important method under preparation of aromatic acids, that is Kolbe-Schmitt reaction, which is also called as Kolbe reaction. Okay, are you all ready students? Okay, put the side heading Kolbe-Schmitt reaction, spelling Kolbe hyphen SCH. Here students, SCHMIDT, Kolbe-Schmitt reaction. Now first we will write the reaction, then we will try to understand the mechanism of the reaction. Okay students. So write down. This is sodium salt of phenol, C6H5ONa. Benzene ring and ONa students, C6H5ONa. If Na is not there and if H is there, what is it called students? Phenol, right? In the place of H there is Na. So it is sodium salt of phenol. Plus what are we adding here? CO2. To this, when CO2 is added and heated up to 125 degrees centigrade under 6 to 7 atmospheres pressure, then what is happening? Next look. C6H5 OH COONa. What is being formed? I will tell you how did we get this, everything I will show you in the mechanism. So this is sodium salicylate, SALICYLATE, sodium salicylate. This sodium salicylate on hydrolysis minus NaOH. So NaOH will be removed and we will be getting salicylic acid, orthohydroxybenzoic acid, C6H5OH This is called as salicylic acid. This is an aromatic carboxylic acid students. This is the reaction of Kolbe-Schmitt reaction. Sodium salt of phenol on reaction with carbon dioxide and when heated up to 125 degrees centigrade under 6 to 7 atmospheres pressure, we get salicylic acid. And an intermediate compound, that is sodium salicylate, is formed, which on hydrolysis gets converted into salicylic acid. This is the reaction. Okay, now let us all learn the mechanism of this reaction. Put the side heading mechanism. First taking sodium salt of phenol. You know this is a salt, right? So O minus Na plus. O Na means nothing but O, and if you mention the charges, O will be having minus, Na will be having plus here. Fine. Now this negative charge will be shifting between carbon and oxygen. So here a double bond will be formed. Immediately this pi bond will be shifted to this carbon. That means this carbon acquires negative charge. Next. Look here, there is a double bond here. Now no minus on oxygen. And here there is a negative charge created. This is Na plus only. Don't write again here the bond students. It is shifted to this carbon. Now plus CO2. Okay. So in the general reaction we have seen no sodium salt of phenol treated with carbon dioxide. So here CO2 enters and CO2 is C double bond O here. What happens here? So this pi bond, these pi electrons will be shifted to oxygen. So O becomes O minus and C becomes C plus. So this positively charged carbon will be attacked by this negatively charged carbon. So at this carbon attacking this carbon means a bond will be formed between this carbon and this carbon. Okay. So next what is happening? Benzene ring. Here one bond, here one bond. Double bond O Na plus, and now this carbon is attached to this carbon, double bond O minus. Okay. Now this O minus attracts this Na plus. So Na from this oxygen will be shifted to this oxygen. Next, put an arrow. We will write the next structure. See students, benzene ring, double bond O, C, double bond O, O, Na. Okay. Now, I am writing one hydrogen separately here. This is already hydrogen which is present on this carbon, students. Okay. Now, I am writing it to show the shifting and all. Okay. Now, so what happens here? This bond between carbon and hydrogen will be shifted inside the ring. That means a double bond will be forming here. This pi electrons shifting to oxygen and this hydrogen will be going out as H plus. Okay. So that's the reason I have written here minus H plus. Next, benzene ring, all three bonds inside, oxygen, this pi electron shifted to oxygen, so O minus. Here C double bond O, ONA, I have written COONA. Now this hydrogen is not there, which has come out as H plus. Now this H plus will be taken up. The same H plus which is coming out here will be taken up by O minus. See students, if you understand, here itself we can show this H coming to oxygen. Okay, but too many arrows will confuse you. That's the reason I have taken one more step. The same H plus, if you understand here itself, this H shifting to oxygen here itself you can show and directly write here OH, no need of showing O minus. Okay, so some students it will be confusing. That's the reason I have taken one more step and here showing addition of H plus, this O minus taking up H plus. So next we will get here this benzene ring OH COONA on hydrolysis. This is what students, do you remember the name of this? Sodium salicylate, right? Sodium salicylate on hydrolysis, addition of water molecule. Here the bond breaks, H this side, OH this side. So C6H5 OH COOH NaOH will be coming out and finally the compound is salicylic acid. This is salicylic acid, students. Easy? How did you feel the mechanism? See, while showing the arrows, students, you should be very careful where to put the head of the arrow. Okay, so O minus, the minus is shifting between carbon and oxygen. This bond is shifting to this carbon. So here double bond, here minus. Next, now here carbon dioxide enters and what happens in carbon dioxide? This pi electron shifting to oxygen. So O becomes O minus, C becomes C plus. This minus will be attacking the positively charged carbon. That means a bond will be formed between this carbon and this carbon. See, I have written here C. Okay, O minus. This O minus will be taking up the Na plus. So from this oxygen, this Na plus will be shifting to this oxygen. Next is this structure COONA. Okay. Next, show one hydrogen outside of this carbon. These two electrons moving inside. That means a double bond will be formed here. This pi electron shifting to oxygen and this H will be coming out as H plus. Next, O minus COONA. The same H plus will be taken up by O minus. Here OH COONA, sodium salicylate on hydrolysis. The bond breaks up here HOH. So C6H5 OH COOH, that is salicylic acid. So this is all about Kolbe-Schmitt reaction, students. This is the reaction and also the mechanism. So where will we find this equations reaction, students? Kolbe-Schmitt reaction under preparation of aromatic carboxylic acids. Okay, so please kindly note down the mechanism, practice it twice or thrice, then it will be very easy for you, students. Okay, whoever is watching for the first time, please subscribe the channel, like the video and also share with your friends, students. Okay, so take care all of you. Meet you in the next video with a new topic, students.